Today we're going to cover section 2 of chapter 3, and in this lesson we're going to be using parallel lines and transversals. We're still going to talk about those same 4 special angle pairs, but this time they're going to be in reference where our 2 lines that the transversal intersects will be parallel. So here are 3 theorems and a postulate that refer to those angles. So they're all going to begin with the bold up at the top, that if two parallel lines are cut by a transversal, then, and then you'll say each statement, then corresponding angles are congruent, and that is your corresponding angles postulate. Then the second one begins the same way. If 2 parallel lines are cut by a transversal, then alternate interior angles are congruent, and that's your alternate interior angles theorem. The third one, if 2 parallel lines are cut by a transversal, then alternate exterior angles are congruent, and that's your alternate exterior angles theorem. And the last one, if 2 parallel lines are cut by a transversal, then consecutive interior angles are supplementary this time. And that would be your consecutive interior angles theorem. In other textbooks, they're called same side interior angles. So what we're going to do on the next slide is apply these 3 theorems and postulate to find missing angle measures. So the key thing you need to take away from here is that alternate interior, alternate exterior, and corresponding, they're all congruent angle pairs. However, the consecutive angles, the consecutive interior, those will be supplements. We will be using these theorems in proofs, or theorems and postulates in proofs throughout the year, especially when we get to quadrilaterals. Applying these theorems in the postulate. Now, when you're given a question like this, either in homework or a test, sometimes it's easier if you treat the figure like a puzzle. You don't necessarily have to answer the questions in order, meaning you don't have to find the measure of angle 1, 2 in that order. You can find it in any order based on your given information. Now, in this particular picture, there's actually 2 different transversals. So we do have our parallel line markings here. So this line, because it's got the arrow on it, is parallel to this one. And then I have a transversal that's perpendicular here. And then I have another transversal that's going diagonally here. And it wants me to find all of the missing angle measures. So obviously 8 is easy to find because 8 is by that little box, so we can see that angle 8 is 90 degrees. Now, however, for angles 1, 2, 3, 4, 5, 6, and 7, that 90 degrees doesn't help us. So we're going to we could forget about this side of the figure for now and just focus on that yellow line. And this is where we're going to be using theorems and postulates to find those 7 angles. Now, in addition to the alternate interior, alternate exterior corresponding, and same side interior, we can also use our linear pair postulate and our vertical angles theorem. So again, I'm going to fill this in like a puzzle instead of going in order and finding each one in the correct order. So if I just focus on the bottom half, if I just focus first on 5, 6, and 7, I can use, without even learning chapter 3, I could find the values of 5, 6, and 7 by just using vertical angles in my linear pair postulate. Because I can see that angle 6 is vertical to the 130, so angle 6 is 130 degrees. I can also see that angle 5 along with the 130 This is a linear pair. So what I can do here is subtract from 180 to get the measure of angle 5. Oops. 130, and I get 50. So the measure of angle 5 is 50 degrees, which is also vertical to 7. So 5 and 7 are both 50 degrees. Now this is where I'm going to pull in my special angle pairs. And you can do this more than one way. I can either use my alternate interior angles to find the measure of 3 and 4, or I could use my same side interior or my consecutive interior and use the fact that those are supplements. I'm going to go ahead and go with the alternate interior because then I don't have to do any math. So I can see that angle 5 and angle 4 are both alternate interior angles. So angle 4 would be congruent to angle 5, which is 50. I could say the same thing about angle 130 and angle 3. These are also alternate interior. So the measure of angle 3 is 130 degrees. And then now I can use my vertical angles in my linear pair, or just the fact that they're all vertical angles. So here, if 3 is 130, so that tells me 2 is 130, and 1 would be vertical to 4, which was congruent to 5. So if 4 is 50, so is 1.
Miss Corey?
Yes.
So, where I'm confused is I get how the 130 minus the 50 for, let's say, angle 5
Yes.
is 50, but why didn't you add in the 90 degrees from angle A since it's on the same line?
Because that's because it's not sharing the 180. Those are two separate things. That's why I crossed it off.
Oh, okay. Okay, thank you.
Mm-hmm. Now again here, notice I've got actually 2 pairs of parallel lines. So I actually have parallel lines here, and notice these double arrows. And then these are also parallel. So I can go about finding these missing variables lots of ways. You can, depending on the pair of parallels you choose. So the first one I think I'm going to go for is, and again, you don't need to go in order. Well, let's go ahead and find in order. Let's find x first. If you notice, if you use the yellow parallel lines, and then you use this as a transversal, x and 110 are same side interior, so these would be supplements. So to find the value of x, I'm going to do 180 minus 110, and the value of x, and in this case it's the whole degree, is 70 degrees. And I'm going to fill that in because I may need that angle to find another one. Now if we go in order, let's look at angle x and angle 2y. So again, if I look at these two as being the parallel, and this is the transversal, 2y and x, these are corresponding angles, and I know that corresponding angles are congruent. So I'm going to set 2y equal to what I just found x to be, and that's 70 degrees. Divide by 2, and y equals 35. And lastly, for z, again, I could use these same lines being parallel, but now I'll use this transversal. And again, 2z and 110, these are also corresponding angles, and I know that corresponding angles are congruent. So to solve to find z, I'm setting 2z equal to 110, divide by 2, and z equals 55. The next slide, it says, when sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 is 40 degrees. What is the measure of angle 1, and how do you know? So my yellow lines here, these are the parallels. See the little arrow on them? And then the purple line, this is my transversal. So we're referring to angle 1 in relation to angle 2. So based off of that, I could see that angle 1 and angle 2 are alternate interior angles, and I know that alternate interior angles are congruent. So if angle 2 is 40 degrees, so is angle 1. So these are alternate interior angles, and each of them is 40 degrees. So the measure of angle 1 equals 40. Now, this last slide is actually a proof for the alternate interior angles theorem. Now, technically, if you were given a proof like this on a test, you could do it in 2 steps. You could have done it in P parallel to Q is given, and then your proof statement, prove that 1 is congruent to 2, and you would say, by the alternate interior angles theorem. But because we're proving the proof, we can't use that. So, but again, you would just do this in 2 steps. You wouldn't have to do this process, but I want to be able to demonstrate the logic behind proofs. So statements and reasons. First one will be P is parallel to Q. That's what those 2 little lines represent. Now my next statement could be that 1 is congruent to 3. And that reason would be the corresponding angles postulate. Now, if on a test you told me this was the corresponding angles theorem, I wouldn't take off points. I'm okay with you mixing up the word theorem and postulate on these 3. This is the only postulate. The other 3 are all theorems. However, if on a proof you mess up theorem and definition, that's totally different, and you would lose points for that. All right, number 3, I'm going to bring in my vertical angles theorem, and I could say that angle 3 is congruent to angle 2, and the reason why I know that is the vertical angles congruence theorem. Again, if you want to abbreviate that as VAT, that works too. And now lastly, my last step is what I was trying to prove, and I can say 1 is congruent to 2, and my reason would be either transitive, because these 3's cancel, or substitution. I would accept either one. So that's the last slide for section 3.2.
Yeah, just a little bit. Okay, thanks.
You're welcome.